Thank you very much, Shelley, for having me. I really appreciate the opportunity to give this talk. I think this is time number 10, believe it or not, from the weirdness that's just been going on. Without wanting to distract too much from the topic of the talk, though, if you don't know who I am, if you haven't heard my Aussie accent before, I am Matthew Setter, as Shelley said. You might know me better as Setter MJD on Twitter, or hopefully the voice of the Freely Geek podcast. To put me in a bit of context as to why am I standing here and giving this talk, I've been writing code in one form or another for about 20 years, judged by the grey hair, most of it web-based apps. I do prefer to forget that a long time ago in a galaxy far, far away, I wrote Visual Basic on Microsoft Access. However, little joke aside there, I've spent an ever-increasing amount of time over the last 4 to 5 years with Docker and Docker Compose and containers, and given that investment and my overall enjoyment of it, I wanted to share what I've learned in the hope that those learnings can help others. So, what will you learn in this talk this evening? To be fair, that's a little bit hubristic to say what you will learn. So while I can't guarantee what you're going to take away from this talk, what I hope to impart to you is, as it kind of says on the proverbial tin, how to deploy applications using Docker Compose. I see that I've still got PHP in there, so please allow for my kind of PHP-centric bias. So if you're using another language, then just insert that one in instead. It isn't a deep dive into Docker Compose, but rather covers the essentials, the foundational information that you need to know to get up and running and to deploy to a remote host. More specifically, here's what I hope to impart. You're going to learn how to build a Docker Compose-based local development environment, or how to Dockerize or containerize your applications. You'll learn how to deploy the application locally, learn how to build and tag self-contained Docker images, which are required for a deployment to a remote environment, how to push those images to a remote image registry. That way, no matter where the deployment is made from, no matter what makes it, the images which make up your application will be accessible. And finally, how to deploy an application to a remote environment using Docker Compose. Now, for deploying with Docker Compose, to make the most sense, you need to really understand Docker's architecture, or what would you say, the 30,000-foot overview of how it works. So quoting the official documentation here, Docker uses a client-server architecture, or a sort of a client daemon architecture, to use a bit more specific Docker terminology. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your containers and all the other things that go on. The Docker client and Docker daemon can, and by default do, run on the same system, or you can connect a Docker client to a remote Docker daemon, wherever that may be, bare metal, virtual machine, you name it, where that machine may be. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface, just for a little bit extra detail. So given that, you can use Docker Compose to deploy to your local machine, or to a remote host, or as part of a workflow tool such as GitHub Actions or GitLab or Circle CI and whatnot. No extra commands such as Docker Swarm mode or Kubernetes are required. To be fair though, there are more advanced ways to deploy applications with Docker Compose or with Docker than I'll be covering in this talk, and Docker Compose, to the best of my knowledge, was only designed for deploying to a single host. But depending on the requirements of your application, which are fundamentally the most important thing, this approach may be all that you need. The main thing to keep in mind is just which Docker daemon the client is connecting to. So, what are you going to need? Well, honestly, not that much, just a broad familiarity or understanding with Docker, such as terms like image, container, and service, Docker Engine or Docker Desktop, I realized that I think it's the licensing model is a little different to what it used to be, but we don't need to get into that tonight. Or sorry, this afternoon. Next up is Docker Compose. Things may have changed since I sort of got into this, but regardless of the operating system that you're using, I still have the recommendation to use Docker Compose version 2. While you can use version 1, I've found personally version 2 just deploys significantly faster. Then you'll need access to an image registry service or application such as Docker Hub, which is available for free, thanks initially for free. I believe there's a paid option, DigitalOcean's Container Registry, or Docker Registry, which is, I think, the open source implementation. And finally, naturally enough, a deployment server running Docker. So a little bit more housekeeping before we sort of really start to dive in and do all the work that needs to be done, which is let's have a little bit of coverage of the demo application that I'll use throughout this talk to kind of give the application a bit more of a sense of realism than just hello world. It's a small one, looks amazing, not at all. It's just for a bit of context. It uses PHP's Mezio framework. There's no need to be familiar with that. Just sort of insert your language's framework of choice or whatever you use if you don't use PHP. Here it is in all its glory. What it does, if you're not familiar with kind of what I'm trying to do here, is it lists the main cast of Hawaii 5.0 from the 2010 to 2020 reboot, including the actors' profile pictures, names, and character names. It's not that sophisticated an app, rather a simplistic one that reads records from a MySQL database and renders them on a single page. It doesn't make use of logging, queuing, or caching services because I've deliberately kept it relatively sort of simple and modest so that it doesn't detract from the real purpose of the talk. Now, as a bit of kind of background, as cheesy as this might sound, if you're kind of wondering why I've kind of run a Hawaii 5.0 theme throughout the talk, it's because I really genuinely did, hand on heart, love the series that much and was so inspired by it that, and my wife actually as well, that we got married on Oahu back in 2012 at just down the coast from Turtle Bay Resort. So yeah, there's a genuine reason as opposed to I just kind of picked something that I just wanted to go with. Now, digging deeper into the app, it will need 3 services for it to function. These are a PHP runtime, because we're using PHP. Again, just insert Ruby, Go, whatever your preference is if you don't use PHP. A web server to serve static content, in this case, NGINX, and a database server to provide the dynamic information. I've gone with MySQL, but use whatever database most makes sense for you. This composition nicely follows the Docker ethos of one process or service per container. Now, let's, what would you say, have the proverbial rubber meet the proverbial road and work through the core files that you'll need to do a deployment to your local machine. I usually use, as you can see here, a somewhat simplistic file and directory structure, one located in the root directory of a given project. Not always, but mostly. And that's in a directory named Docker. I don't have a particular reason for this, other than I just noticed it was what people seemed to do when I was getting started, and it worked for me. It was kind of logical, intuitive to me. But regardless, this top-level directory is subdivided into directories for the services within the application's configuration. Then, within each of the service directories is a Dockerfile containing the instructions for building the underlying image for that service, which we'll see throughout the course of the talk. Then, alongside the Docker files are any supporting files for that service's image. You could have a more sophisticated structure than I have here, but to try and keep things nice and sort of simple on the slide and not have the font size be too small, I just tried to keep it as kind of simplistic as possible. Now, what I did sort of some time back was I used to have a separate Dockerfile per environment, but I'm now using one Dockerfile for all environments and taking advantage of multi-stage builds, which I'll kind of delve into more and more throughout the talk. The reason for that is just I've found for myself, having fewer files is just easier to sort of keep in my head, easier to debug, easier to create. Now, finally, there's a base Docker compose file, which is dockercompose.yml, which contains the configuration that is applicable to every environment. And along with that, there's a Docker compose file per environment. Now, these files contain a combination of additional settings and overrides to existing settings. I found that this approach, just to reiterate, is just, for me, easier to create and maintain and manage. So let's start working through the Docker files for each of the relevant services. I'll start off with the PHP service. You can see here from the highlighted line that it starts off with the from instruction, which bases this image on the official Docker Hub PHP image, the one that uses PHP 8.11, in tandem with Alpine Linux. Note that it adds the string as development at the end of the instruction. This enables the first of two stages in a multi-stage build, this one being used only for development. If you're not familiar with multi-stage builds, the official documentation, which you can see a snippet of here, says with multi-stage builds, you use multiple from statements in your Docker file. Diving a bit deeper, multi-stage builds have a host of advantages, such as making it easier to build a Docker file that supports multiple environments with one file instead of splitting that across multiple files. Each from instruction can use a different base image if that's relevant and applicable, or each one could use the same base image. But each one of them begins a new stage or phase in the build. Because of this, you have quite a bit of flexibility and power, such as being able to selectively copy artifacts from one stage of a build if you're sort of working through multiple stages, and then take it across to another stage, leaving every single thing else behind that you don't need in any subsequent stages or the final image. I guess it's worth noting that while multi-stage builds can add complexity because you sort of, I guess, have to put a bit more thought into how you organize them, when done well, they can both simplify the build process and reduce the final image's size, which is great for if you're cutting down on deployment times and reducing image hosting costs, I guess, among a series of other really good advantages. Now, next comes your run instruction, or in this case, it does, sorry. In this case, it will install the PDO MySQL extension so that PHP can interact with the backend MySQL database. And then it installs Xdebug, which provides step-through debugging for the development environment. I've not added any other common development options or any of the dependencies which you may need, which you normally would in a development setup, mainly just for the sake of space, but kind of, I guess, just envisage here, if you'd like, any of the other things that you might normally have to add to make sure your development environment was up and running as you needed it to be. Now, let's step through the second stage. Again, based on the same base image, but this time named production. So the first one for development and the second one for production. As before, it installs the PDO MySQL extension. It then sets the working directory or the base path within the image where any subsequent instructions will operate relative to, if relative paths are used, which is just handy for later on, kind of saving reuse of adding that base path sort of throughout the file. Then it copies over all of the app's source files into /var/www/html within the image. And finally, in this case, it mounts version 2.2.7 of the official Docker Hub Composer image, which, if you're not familiar, is PHP's dependency manager. And then from that mounted image, with which, what would you say, mounted or is connected to this stage of the build, makes /user/bin/composer in that image available within our image in the same location. Then it runs composer install to install the dependencies listed in composer.json. Now, if you're not familiar, composer.json is the configuration file for Composer, which lists all of its dependencies, quite similar to package.json for NPM and the configuration files for the various package managers in other languages. If this is kind of all new for you, then just, I guess, sort of imagine what you would do for a production image for your language or framework of choice. Before I move on to the Databases Dockerfile, I just want to cover a few little multi-stage build time-saving tips that I came across over the last couple of years, or friends were kind enough to share with me. Each of the 2 stages that we've stepped through in this Dockerfile started off using the same base image. Now that's fine, but as with code, hard coding strings can lead to errors if you're not careful and very diligent. Especially if, say, for example, one or more of the from instructions was updated when switching to, say, a new version of PHP or the Alpine image. So one's using one, one's using another, and you sort of start wondering, why is the application working in sort of different ways in these 2 environments? So instead of explicitly naming the base image in each stage, as I've done here, you could use some Dockerfile arguments, such as in this example. In this case, the PHP and Alpine Linux version strings have been defined as arguments, which are then used in string interpolation in the from directive that follows. That way, if one or more of these 2 arguments changes, if we move to like a later version of PHP or Alpine Linux, then we only need to change the arguments here in the Dockerfile, and each stage that uses them will be changed automatically. You could also set these in the Docker Compose file, as I'll cover later, which could be helpful if you're working with multiple versions of your language of choice, or you're sort of changing, I guess, any other relevant setting. In addition, you could use one stage, as I have here, as an alias, as stages don't need to contain any instructions. By doing that, as I've done here, each subsequent stage can be based on that alias stage. And in so doing, you give it a shorter, more meaningful, more intuitive name than sort of like the much longer, what would you say, your language, your version, or your web server and whatnot. Now, let's look at the Databases Dockerfile. The reason for this Dockerfile is really just to simplify creating the database and loading up data into it when the container is started. That way, when the application is deployed, the database is ready to go. Now, I appreciate that there are a host of ways that you could do this, and in all likelihood, you'd probably use a professional database hosting service, such as DigitalOcean's Database Service, ScaleGrid, Heroku, and whatnot, perhaps in tandem with a migration tool for your, like the one of your personal preference. But for sakes of simplicity, I'm just going with it, with this way tonight. And to help put that into more context, the copy instruction here copies a SQL file, which we'll cover a bit of in just a moment, into Docker entry point initdb.d inside the image. And the reason for that is because when a MySQL image is created, if it finds a file ending in .sh, .sql, .sql.gz, or sql.xz in that directory, then it'll run it. So kind of in effect, it's a what would you say, like a lazy man's or poor man's database loading and initialization tool. So because the app's so simple, there's really not much to the database dump file, but I thought I'd cover a bit just to the kind of full transparency. You can see here the first part is that it creates one of the tables with the relevant columns and so forth. And the second part, it then loads a series of records into that table. Now with the Docker files and their supporting files ready, let's now work through the Docker Compose files. Starting off with the base one, which is docker compose.yml, Docker Compose's primary configuration file. The configuration starts by setting up a persistable file system volume, which is used or will be used by the database container. This is important because while file systems in Docker containers are writable, they don't persist changes across container restarts. This is because when a container is started, it uses the specified image at the time that it was created, or should I say uses the file system as it was when the image was created, which naturally doesn't have any new files nor changes to those existing ones that will make. This can be okay, depending on what you're after, but it's not a great thing when working with databases or other storage mechanisms. Hence, why we're creating a persistable file system volume, where any new files and changes to existing files can be kept across container restarts. We next define an element called services. Now this element, which I've split up over a number of slides, lists the definition of the three services or containers which will make up the application. It starts off with the NGINX container. Given that it's named NGINX, the container will have a matching hostname of NGINX as well. Note that it doesn't contain an image option to specify a base image to use or a build option to tell it where it gets its build instructions from. These will be specified later in the environment-specific Docker Compose file. Next, it sets the restart directive to unless stopped. By doing this, Docker Compose will restart the container if it should crash or stop for some reason other than when running Docker Compose down. Now, one thing is worth bearing in mind here in this highlighted line, and that's the ampersand restart policy between restart and unless stopped. Now, this isn't Docker or Docker Compose specific. This is a YAML anchor, which helps you, in short, avoid repeating yourself. Or again, hard coding something throughout the file. In this particular case, what's happening is that the anchor restart policy has been created, or sort of created to that value unless stopped, which later services can then reference. So that way, they can all use the same value without, again, hard coding it multiple times, just making it easier to maintain. Now, the restart directive supports 4 values. These are no, or in no particular order. No, what happens then is Docker doesn't restart a container for any reason. It's worth noting, though, that if you use no, you have to double quote it, or I think it's single or double quote it, because I think it's something in the Docker Compose parser will cast that to a Boolean. A friend pointed that out to me a little while ago. Next value is always. Here, Docker will always restart a container if it stops. If it's manually stopped, it's restarted only when the Docker daemon restarts or the container itself is manually restarted. Then there's on failure, and in this case, Docker will restart a container if the exit code indicates an on failure error. And unless stopped, we've already seen. Now, next up, the depends on option creates a dependency between this service and the PHP service. In short, it means that NGINX won't start until the PHP service has started. So I guess if you have, like say, you just have like a dependency graph, something has to wait for another to start, then you can do this to make sure that your containers sort of start up in the right order. It's not overly sophisticated, but does do a nice job. Now, the last configuration that you can see here is to add a health check. Now, these determine, as the name kind of implies, if a container is considered healthy or needs to be restarted. Health checks can be whatever you want them to be. There are no hard and fast rules around what they are. They're sort of it's a user defined as makes most sense to your container. Now, Mezio applications, the framework that I've built the test app with, come with a ping endpoint. I guess a lot like a lot of API toolkits and frameworks do, which return a JSON response, which contains the current timestamp. So it's a simplistic way of testing whether the application is sort of still alive, still working. To work through the health check options, the health check will make up to 3 curl requests to the endpoint that has been specified in the test directive every 60 seconds, allowing for a 3-second timeout. If 3 attempts to the endpoint fail, the container is considered unhealthy and is restarted. Now, the configuration for the PHP container is, in this case, quite small, but similar-ish to the NGINX container. You can see that it starts by naming the service PHP, so it gives it a host name of that as well. And it then sets it to restart if it should stop, unless we stop it, by referencing the YAML anchor restart policy that we defined in the NGINX service. Finally, for the database service, as with the other containers, it's given a name, which gives it a host name, and it's set to always restart unless stopped. This time, though, we're using the build directive to tell it to use the Dockerfile located in docker/database, which we stepped through before for its build instructions. And now, let's get into docker compose.dev.yml. So we're going to now work through the development specific settings or extended settings and overrides. You can see here all of, well, the start of the definition which is reasonably similar to what we defined before. But there are a few differences. The first being that the NGINX image uses the image option to tell it the base image to use, specifically the latest version of the official Docker Hub NGINX image. Then it uses the ports option to map port 80 in the service or the running container to port 8080 on the host machine. And then the custom NGINX configuration file, which we'll see next, is copied into the image in place of the default version. The reason for that is that there were just some settings that I usually like to override. There is another way to do this, but it would sort of take a little too long to sort of get into and explain. So I thought I would go with this approach just for, again, sakes of simplicity. After that, in the second volume option, because of that, it will the current directory on the host machine will be mounted inside the container at /var/www/html, which has the effect of letting us develop locally on a host machine, yet have the code be accessible to that container. In effect, it's like sort of sharing your local directory with the container, rather like tools such as Vagrant's shared folders. When you make changes in your development environment, the changes are almost instantly available to the container as well. So there's no need to manually copy or sync files between the dev environment and the container. Now here is the amazing NGINX configuration file. Not really. It isn't all that special, and I've taken out other parts that I usually use. The main reason is just to focus on the core reason why I overrode the file in this case, which is to extend the default NGINX configuration to send all of its requests to /public/index.php, and then pass off PHP requests to the PHP service on port 9000. Not really kind of that interesting per se, but again, just to sort of, for completeness, I wanted to share that file. Now, for the PHP service itself, build directive through the context and Dockerfile subdirectives tells it to use the Docker file located in docker/php, which we stepped through before, for its build instructions. By adding the target subdirective there underneath the Dockerfile subdirective, we're telling it to use the stage named development, but stop when it's worked through those instructions, and in effect, skip any other stage. If we didn't specify this, it would just start at the first stage in the file and work through to the end, which isn't what's desired here. Then, as with the NGINX service, it maps the local directory on a development machine to /var/www/html in the service. www is still a bit of a mouthful. Finally, regardless, let's look at the changes for the database service. First up, this time it sets the environment option. In here, we can pass environment variables to the container that are relevant for it to run. In this case, we're setting 3. These are for the database user's username and password, and the database name. If you're interested, you can find a list of the predefined variables for this image in the image's official documentation. Then, using the volumes directive, we're making any changes in /var/lib/mysql, where MySQL stores its data files. We're making those permanent, as they'll be written to the persistable file system volume that we set up earlier. And finally, it maps port 3306 in the container to the same port number on the host machine. The reason for that is that in development, you can then use GUI tools such as DataGrip, Navicat, or whatever your tool is of choice for working with your database of choice, or in this case, the MySQL command line client for interacting with the database, maybe manually loading more records or changing them, adjusting a schema, and so forth. But at this point, we have now finished the Docker Compose configuration, so it's time to test that it works by deploying it locally. And for what it's worth, this is the majority of the work that you need to do. Everything else at this point just builds on what we've already done. So to make a deployment, we call Docker Compose up, as you can see here in this example. And to that command, we pass the file option twice, one for each Docker Compose file that contains collectively all of the configuration that Docker Compose will need. You could also use the shorter F option if you like, if you prefer shorter options. However, it's really handy, and this is what I've come to really love lately. You don't always need to specify config files. The reason for that is, as I've mentioned before, Docker Compose.yml is the default configuration file that Docker Compose looks for, unless you specify something else with the file or F option. But it also has a secondary configuration file called Docker Compose.override.yml, which, as we were doing before with the environment-specific files, contains additional settings and overrides of existing settings. So if you like shorter commands, like I do, and less work and less potential points of failure, so when you're really tired, when you're under stress, when you're under the pump, all those things, it's harder for things to go wrong. Or if you're using a build tool, it's harder, again, for things to go wrong, things to get missed. Try this. Do what we've done so far with the base file and then your environment-specific file. And then, I can't speak for Windows, but for Mac OS and Linux and BSDs, symlink your environment-specific file, such as, in this case, dockercompose.dev.yml, to dockercompose.override.yml. The net result of that is now you don't need to pass the file or F options. Your commands are a lot smaller, and there's so much less to go wrong. It's so much easier to just get it right. Anyway, regardless of the approach you take, after the command runs, you'll see each container, as in this example here, being created and started. Now, it may take a few minutes because if the base images that one or more of the containers used isn't in the local Docker image cache, then naturally it needs to be downloaded. So allowing for the speed of your network connection, that should be done reasonably quickly. But after that, everything, like any time after that you start, it'll be up and running quite quickly. After that, you'll see each of the containers launch, and from then on, until you press Control-C, all of the output, which you see in kind of the bottom half of this slide, will be printed out continuously to the console. So anytime you make a curl request, load the site in a browser, if it's a site, use Postman or another tool, you'll see the relevant logs appear in your terminal. As a bit of a time-saving tip, if you'd like to kind of, what would you say, pre-warm your Docker image cache, you can use the Docker pull command, similar to these examples, to pull down the relevant images that you're going to use. So that way, the first time you run Docker compose up, it'll run as fast as possible. Now, I apologize for skipping around in the slides there, but this is what I do when I'm kind of usually first building something new, because like anything, you can make mistakes in one or more of the configuration files. A configuration file might be missing, or the path that you've specified might be, for sakes of one character, incorrect. So in short, something might not be quite right. So by letting the logs print out to the screen, you can then see if something is going wrong, press Control-C, attempt to fix it, start it up again, and sort of iterate over that process until it's running smoothly, at least as identified by the logs. At that point, then add the D option, or you could use the longer detach option, as I've sort of slightly exemplified here. And at that point, what happens is that after the containers start, Docker goes into detach mode, where the containers are run in the background. So then you can use the terminal for whatever else you want to use or may need to. But because it's detached, logs aren't printed to the terminal. So you may then wonder, are the containers working as expected? So it's handy to check if they are. So two ways you can do this are the Docker compose PS and Docker compose logs commands. Starting off with Docker compose PS, as you can see here, this command is analogous if you're familiar to Linux's PS command, which displays process status information. If we run it, as you can see here, it will show a list of all of the containers in this particular configuration, including their name, state, and ports. This way, you can kind of, admittedly superficially, but quite quickly, see if all of the containers are up and running, or if there's a problem with one or more of them. In this case, there isn't, as identified by running being listed for each container in the status column, the second from right. However, if you saw restarting or exited, you could then know that something's gone wrong with that container. Now, if you weren't interested in all of the containers, just maybe one, you could then run compose PS again and pass the name of that container after it. If you're interested in 2 or 3 or more, depending on the size and complexity of your configuration, just pass in the names at the end of the command, space separated. Now, the same thing kind of follows for the logs command, as I've demonstrated here in this slide. Again, this will filter all of the available logs just down to the logs for the database container, but space separated names of each container, and you'll filter in the logs for those containers. What this will do here with the follow option is consistently, what would you say, poll and print the logs for the relevant containers to the terminal until you press Control-C to stop it from doing so. I find this handy because by default, it will print the tail end of the logs and then stop. But if you're tending to sort of debug it, doing curl requests, ping requests, or whatever tool that you use, you'll have to keep kind of repolling the logs to get that information. So pass the follow option and it will just keep printing the logs until you choose to stop at the end of your debugging. Anyway, let's assume at this point everything's running nicely. The app works. If we loaded localhost on port 8080 in our browser, we'd see the application working kind of like this. So we know that everything's fine. At that point, just to further reiterate, we have done the absolute majority of deploying anywhere. But before we move on and go to a production-specific configuration, let's just have a quick recap to see just how much we've achieved at this point. We've created a directory structure to store the Docker files that we need, along with any supporting files. What's more, it's nicely structured around environments. So this way, if we want to add more environments later, we can build on that existing structure. We've created Docker files for each of the 3 services that compose our application, which we'll later use to create the images with which Docker Compose used to launch the containers with. We based each image on an existing base image so that we only really had to do as little as possible, but gaining a lot of functionality right out of the proverbial box. We then created a 3-service Docker Compose configuration with a combination of a broad base Docker Compose file, which was then complemented by an environment-specific one. The configuration used the Docker files which we created, one that supported health checks so that we know if a service was ready or not, which synced the source files to the running container, yet let us work locally without having to copy over files when we changed them. We set environment variables, configured the services to auto start if they crashed, and made a database service available to local database tools. Then we learned how to start or deploy the application locally using one command, and we learned how to do some, albeit basic, status checking and debugging should something go wrong. I think not bad for, a relatively short period of time. But let's now rapidly bring this to a close by creating the production files and making a production deployment. The first thing that we're going to do is create a Docker file for the NGINX service. It wasn't necessary up until now, as the NGINX service in the development environment used the official Docker Hub image with no special changes, but for production, that's not going to work. So the Docker file uses the latest version of the official Docker Hub NGINX image, specifically the Alpine version. I love Alpine. It then sets the base path where subsequent instructions operate relative to. Next, 2 copy instructions are used to copy the custom NGINX configuration file, which we saw earlier. You may use a production version one, which has more like sort of better tuning, security, and so forth. And it'll put that inside etc. nginx conf.d, and then it copies over the contents of the current working directory, all your app source files, configuration, and related files into the image inside /var/www/html. Then it uses Alpine's package manager, APK, to install the required binaries that the image will need, and runs npm install to install the front-end dependencies. And with everything in place, it finishes up by using npx and Tailwind CSS to build the application style sheet from the base configuration instead of generating a sizable development version. Now, there's a little bit of errata there. The generated style sheet will only contain the required CSS properties, and after it's built, will be minified. This way, the file in production will be as small as possible and be generated only when required. If you're not familiar with NPX or Tailwind CSS, or kind of, I guess, more of what's going on, the intent here is just to sort of simulate what you would likely do in a production environment. Now, we need to create the production Docker Compose configuration file. It'll have the same services with largely the same configuration for each one, but there are a few little differences to pay attention to. The NGINX service now uses the NGINX image, which we'll create in the next section. And instead of mapping port 80 in the NGINX image to port 8080 on the host, it'll map it to the standard port 80 instead. And for the PHP service, similar to the NGINX service, it'll use the image which we'll create shortly. Now we could and likely would add in other options here, but for sakes of time, I've skipped over that. For the database service, again, it'll use the database image, which we'll create shortly. And secondly, when in this case, based on not explicitly passing values for each environment option, what's going to happen is that Docker Compose will look for and set those from the environment where Docker Compose runs if they're available. Now, as I'm sure we're all aware, there are so many ways to set environment variables, but for sake of simplicity, we're going to use the Linux export command, as in this example, to set them in our environment. So let's just imagine that those three commands will run. Now that the Docker files have been created, we are getting so close to the end, so it's time to build the images from those Docker files and push them to the image repository. To do that, as you might expect by now, we'll use the docker build command, as you can see exemplified here. Note the options supplied to each command. First, there's the file option. You could use the shorter F option to provide the name and path of the Docker file containing the build instructions. We're doing this as, at least in my case, or the one that I built this talk from, the Docker file isn't located in the directory where the docker build command will be run. So we provide like an alternate path to the file. The path to the image's context, or the dot or the period right at the end of the command, is the directory that all the commands will run relative to. And finally, the tag, or also the shorter T option if we chose to use that, this provides the tag for the image. Now, there are a few interesting things to note about that. Note that the tag label starts with, in this case, webdev with Matt, which is one of my Docker Hub usernames. By doing this, when the images are pushed, the information doesn't need to be specified, as it will be automatically retrieved from the image. We could also supply a Docker registry URL if we were using a service other than Docker Hub. We've also given the image a name and a tag. Now, we could call these whatever we want within reason, but I guess like anything in computing, naming things is hard. So ideally, as long as these names are meaningful and unique for your account, then I guess within reason, call them whatever you want. But regardless of those choices, once the images have been built, we can confirm, we would, I guess, next need to confirm that they were built correctly. And we do that with the docker images command. Here is like assuming we only had these three images in the local Docker image cache, this is what you'd see. So you'd see the repository name, the tag, when it was created, its size, and the image ID. However, if, as is usually the case, you're working on a number of projects, if you're a freelancer for a number of clients, if you're not self-employed, maybe like on a number of projects, you might have just quite a large amount of images that display when you run Docker images. So you can, as a brief example, you could use the filter option just to filter down by some characteristic of the images that you're looking for to filter out all the noise. But regardless of that, we'll now assume that the images are built and tagged. So it's time to now push them or store them in a remote image registry. That way, they're accessible no matter where the deployment is run. For the purposes of this talk, as I've indicated, I'm using Docker Hub, but if you prefer, you could set up a local Docker image registry using Docker Registry. It's a really awesome tool. A touch slow, or it might have just been my machine, but it's a really great tool to kind of get started locally, or you could use a different service such as DigitalOcean's container registry. Just a quick plug. I'm not getting paid to plug DigitalOcean. It's the service that I've used most often, so I'm most sort of comfortable with it, and it's the thing I most refer to. But if you use something else, then just kind of swap in that instead. As you might expect, we'll use the Docker push command to push the images to a remote image registry. Before we can do that, though, at the top of the slide here, you can see that we run Docker login. So that way, we authenticate the current session to whatever remote image registries that we're using. And I guess another little thing is that, at least with DigitalOcean, I believe other services do the same thing. You can use their authentication tool. I think in the case of DigitalOcean, it's the doctl command, but it can seamlessly integrate with the Docker login command. If you pass in the relevant details, it'll transparently authenticate with that service. And I believe a number of other services do the same thing. So you can kind of stay within a Docker specific tool set. Now, before we deploy the application to production, as is always good in many things, but especially with software, is test, test, test. So let's test the production deployment locally. So that way we can be as sure as is practically possible that it's going to work. And we do that, really, we're not doing a whole lot. Assuming that we symlinked the Docker Compose dev file previously to Docker Compose override, this time we would remove that symlink and instead symlink it to the production Docker Compose file. And then, as in the second command, we'll just run Docker Compose up. We can then use Docker Compose PS and logs to check that everything was working. I guess the only real difference being that we would use the images that we've built that are stored in the local image cache. Let's assume, for the sake of time, everything's working beautifully. We can then shut down the deployment by running Docker Compose down. And now it is time to finally deploy to production and see that really there's no special magic. There's no extra set of tools that you need. But there is one thing that I do need to go over before we do that so that it works. And that is, we need to tell, harking right back to the early slide in the talk, that we need to tell the Docker client which Docker daemon that we're connecting to, in this case, the one on our fictitious imaginary remote host. To do that, we can pick one of three choices. We could set the Docker_host environment variable before or while running Docker commands. We could use the capital H or host option with Docker commands, or we could use a Docker context. Now, focus in on the first two there and show a series of examples of how they work. Each of these above examples here specify the Docker daemon to connect to. While I did find this helpful in building a GitHub action-based workflow, probably because I was quite new to GitHub Actions at the time, for running commands locally, I do find this quite frustrating, mainly because perhaps I'm getting a little old now, mid-40s and all, and I periodically forget to set an option. I pull an option out of my Linux man history, but it's the wrong one. So I set it incorrectly, and it leads to some mixed up results and some annoying, pointless debugging. So while it's fine, these are fine, at least when running it locally, I prefer and recommend using the Docker context commands. Now, the Docker context is a single, to quote the docs there, a single Docker client can have multiple contexts. Each context contains all of the endpoint and security information required to manage the connection with a remote daemon. The Docker context command, which we'll see in just a sec, does make it kind of easy to configure these and then switch between them kind of at will. To boil that down, by default, there's a Docker context named default, which is kind of handy, that references the Docker daemon on your local machine. So by using the Docker context set of commands, you can add any number of additional ones and then swap between them, which is handy when you're deploying for multiple projects, for multiple clients, and so on and so forth. When working with it, you really only have to do two things, which is create it and then set it as the default. Then run your commands as you normally would. As a quick example, here in the first command, we're creating a context called remote. And on the third line there, you can see where it's going to point to your remote host, whatever IP address or host name. It will connect over SSH and use the user deploy to interact with the remote server. Then, after we've created it, we use docker context use and specify the context name, and any Docker commands we run after that, or Docker compose as well, will use that context or that remote daemon. As a quick thing, if you want to check, because maybe you're not sure which one is in effect, use docker context ls. Look for, in the name column, for the context with the asterisk next to its name. That's the one you want. Sorry, that's the one that's in effect. Anyway, for the deploy to production, that's it. Because in this case, we've symlinked our production Docker Compose override file to Docker Compose override, so we don't need to specify the F or file options. We've got a context in place, so the local Docker client will talk to the remote daemon, not the local one, allowing for firewalls and a few other the joys of remote deployments. That's it. That's how you make a deployment. So, did it work? I won't dive too deeply into it, but as I said before, any command, because of the context, will run against the remote daemon. So now we could run docker compose ps, allow for a little bit of network latency and overhead there, and we'll see the same output, but from the remote daemon. If you want to look more deeply, docker compose logs, same thing again. Oh, one thing I forgot to mention is that just like the local machine, if the base images that the composition requires aren't in the local image cache of the remote daemon, naturally it'll have to pull down those first. But after that, it'll run or start up as quickly as possible each time. So that is the core of tonight. But let's do a little recap just to bring this to a close. So what did we cover in this second part? How to build application images, how to push or store them in remote accessible image registries, how to tell the Docker client which daemon to communicate with, how to build a production configuration, and how to deploy the application to a remote host, production, staging, testing, whatever. While there were sort of many new things to learn about, at this point, you're now ready to deploy an application to any environment of your choosing while staying within the Docker ecosystem. And one last teeny weeny little thing. If you'd like to dive deeper into the topic, then I've written a book called Deploy with Docker Compose. You can find it at deploywithdockercompose.com. It covers a lot more, also goes into a lot more detail than I've been able to talk about tonight. But without going overboard, I like to think. It's packed with tips and tricks and pointers that I've learned along the way and that others have shared with me that I haven't been able to share this evening or this afternoon, I believe, local time. If you're interested, it's free. You can download it from deploywithdockercompose.com. At this point, thank you very, very much for your time. I appreciate I've gone longer than I should have, but thank you for your patience. And if you have any questions, it's over to you.
There we go. Awesome. Thank you so much. That was really, really great. At times I'm like multitasking and stuff like that, but I couldn't do that here. I was like so interested, in everything that you were saying. But yeah, we are overtime, so I will close it out, but I have sent swag codes to everyone. I have 2 more to send. You will get that immediately after this. This presentation will be available on YouTube later tonight or tomorrow probably, and I will email everyone on Meetup to let you know about all of that, and I will include links to Matthew's work as well.
Mhm.
But Matthew, thank you so much. This was so great.